Hello and welcome to section 7.5, solving special types of linear systems. We're going to be we talked about this a little bit in class, but we're going to be working with a couple different types of systems in which there is not just simply one solution. So we've seen that they can have one solution, but there's also systems that can have no solutions or many solutions. So we're going to take a look at what that may look like. What would it look like if it has no solution? So the lines have to be parallel, and they have to have different y-intercepts. So in order for them to have no solution means they can't cross at all. So that would be an example of what it would look like if there's no solution. So parallel lines. Now keep in mind they have different y-intercepts. This, by the way, is called inconsistent. Don't really have to worry about this terminology. I'm actually going to scribble that out because it really doesn't come up too much. And then many solutions. So here, the two lines would have to cross a lot of different times. So the two lines would need to be the exact same line. So they'd have to have the same slope and the same y-intercept. So that'd be many solutions. They're the exact same line. All right. And then, so we just showed that. We just talked about that. So if you want to put these are the notes, kind of that went with what I just talked about. Same lines, so they have the same y-intercept, same slope. Parallel lines, same slope but different y-intercepts. And then if they have different slopes, they're gonna cross somewhere at some point. Okay, so that the system has no solution. Method 1, graph. I'm actually not going to graph these. And the reason why I'm not going to graph them is because I'd have to solve both of those equations for y. It's going to be a lot of work. Rather, I'm just going to use elimination. So I'm going to move this over here. And I'm going to multiply this one by -1. And again, graphing is one method. But those are both in standard form. So that'd be kind of ridiculous to go ahead and use graphing for that problem. All right, what I get is the 3 and the -3 cancel out, the 2 and the -2 cancel out or add to 0, and then 8 plus -2 is, or sorry, 10 plus -2 is 8. So if this is false, if you end up with a false statement, that would be an example of no solution. So those two lines are going to be parallel. They're not going to cross. And then show that this system has many solutions. Okay, so this one here, you have the y equals by itself already, so I can solve this one quickly for y. This one we'll actually go ahead and graph. Now if I take a look at this here, both equations are the same. Y equals 1/2 x plus 2 and 1/2 x plus 2. I don't even really need to graph this. They're the same exact line. So this one's many. And then now you could have said, well, why didn't we use substitution? And that would be another great option because y is by itself. So I can do x minus 2 and then plug in the 1/2 x plus 2 equals -4. And this is the algebraic method. So I'm going to distribute this -2 to both of these. -2 times 1/2 is -1x. Or -x, and then -2 times +2 is -4. So the x minus x is 0, so you end up with -4 equals -4. This is true, and if it's true, it's many solutions. So that's an algebraic method. So you can use graphing, elimination, or substitution for these problems. Again, there's just basically tons of these problems. Just look at it, see what form they're in. These are both in standard form. They're already ready to be eliminated, actually. So the 5 and the -5 equals 0. 3 and -3 equals 0. So you have 0 equals 9. That is false. No solution. And basically, that's the lesson here. This one has a y equals, so I would do a substitution here. I probably should pick a different color. Okay, so -6, and then +3. And then here's my substitution part. 2x minus 4 equals -12. Solve this for x. And the x's are going to eliminate or add to 0, so you have -12 equals -12. This one would be many solutions. So there you go. These are they're called special systems, and I'm not going to solve any more because they're all the same. Just so you guys are aware, in your homework tonight, some of the problems may actually have solutions, so they're not all going to be special because the book throws in a mixed bag of problems. So that's 7.5. Let me know if you guys have any questions. Thank you.